Hello everyone. In this video, we will be discussing the second question of IBSL 2020 Chemistry Paper 2. So in this question, we are given two compounds, compound A and compound B. So here in compound A, you can see it's an alcohol. In compound B, you can see it's a ketone. So predict the electron. The first question says that predict the electron geometry and molecular geometry around the oxygen atom of molecule A using VACPR. So around oxygen in compound A, if I draw, there are two single bonds and two lone pairs. Okay, so hybridization. Okay, the value of Z would be total number of sigma bonds plus total number of lone pairs. So we have two sigma bonds, two single bonds, and two lone pairs. So it is 4. So my hybridization is sp3. So for sp3, the electron domain geometry is basically tetrahedral. And the molecular geometry in this case is bent. Okay, you can check the cases for tetrahedral. If you have two lone pairs and two bond pairs, the molecular geometry becomes bent. Now, moving on to the second question. The infrared spectrum of one of the compounds is shown. Okay, so in the previous question, your compound A was the alcohol, okay, and compound B was the ketone. Now, out of these two compounds, one of them, they have chosen any one of them and they have given the IS spectrum of the compound. Now, reduce giving a reason the compounds producing in this spectrum. So for OH, okay, or for the alcohol group, we know that there should be a dip between 3200 and 3600. Okay, so there should have been a dip somewhere, but this dip is missing in case of alcohol. But we can see that there is a dip between 1500 and 2000. This dip is approximately at 1750. Okay, and we know that for aldehydes the dip should be in this range only. Okay, so yeah. Now, so that's basically the reason. So compound B produces the spectrum because the reason is because we can see a dip at 1750 is a centimeter inverse, which confirms a ketone group. Okay, so this is the answer to question 2. Now in this question, we know that compound A and B are isomers. Draw two other structural isomers with formula C3H6O. Now we need to draw two other structural isomers other than A and B with the same molecular formula. One can be this thing. Okay. I'm just shifting the double bond row to the right side of the second isomer B. And another one can be of A. Okay, just shift the OH in one side. Now, A was this thing. So I can shift this OH here. And this would be my final answer. Okay, so we get two isomers by just shifting the shifting our functional group one position, okay, towards the right. Now moving towards the last question. So here the equilibrium constant Kc of this reaction is given. So if you remember, this was A and this was this reaction B. Now the value of Kc is 1 into 10 to the power 8. So we need to know which compound is present in greater concentration. We know this fact that if Kc is greater than 1, then products are favored. Okay, that means there would be more products. If Kc is less than 1, then there would be more reactants. Now in this case, Kc is very greater than 1. Okay, so obviously B is in greater concentration.